We're working on solving higher order equations, and we have to develop some skills before we can actually attack equations that are x squared, x cubed. And some of that preliminary stuff seems to go on for quite a long time, but it's necessary, I'm afraid. So we want to go here into Howe-Two Software and start down here at the bottom of this column and work our way up. And when we get done with all these skills, then we'll be ready to work on equations that have higher powers than the first power. So let's look at multiplying binomials. Now, I have this all set up so that it generates binomial after binomial, and here we get our first binomial. A binomial is something that has two, like a bicycle, two terms. I'm going to bring up the marker here so that I can draw on this. We've got two terms in this quantity and two terms in this quantity to multiply by. Now, previously we had multiplied using the distributive property, like if we had 5 times x squared plus 2x plus 1, and we had to multiply the trinomial here by a single monomial. We would have to multiply everything in here by that 5. So the answer would be 5x squared, the answer to the multiplication problem, plus 10x plus 5. That's what it means to multiply a quantity times a monomial. When you multiply a binomial times a binomial or binomial times anything else, what has to happen is that every quantity in the first one has to multiply every quantity in the second one. So I'm going to change this, and we'll start with this 4x. So the 4x has to have its turn at multiplying the 6x, and then it has to have its turn at multiplying the 5, and then the -1 has to have its turn and multiplying each of these things, and we will have 4 multiplications. And we can start in with that. I'll make that black, and this 4 6 is 24 x squared, and then minus 20x. Now it's the 1's turn, negative 6x plus 5. And then only like terms can combine. There's only 1x squared, so that would stay 24x squared. And then minus 26x plus 5. So I'm going to minimize, if we can remember, 24 minus 26 plus 5. 24, so I don't have to think again. Minus 26 plus 5. We check, we win. Now, let's talk about what the multiplications that we just did. The 4x multiplied the 6x, and it multiplied the 5. Well, years before I ever took algebra, some teacher probably made up a mnemonic to help people remember all 4 multiplications, because I imagine that some kids would get careless and just multiply 3 things since they got 3 parts to their answer. And the word that the person used was FOIL, and you'll see it in most algebra books, or at least most algebra teachers will resort to it. And the guy or the woman or whoever made it up said the F stands for first term in the first quantity times the first term in the second quantity, then that would be our 24x squared. Then the O stood for the outside. Like if we think of 4 things standing in a row, there are 2 of them on the outside. So here's the outside. Minus 20x. And there are 2 things that are on the inside. minus 6x, and then the L stands for last, plus 5. Now that's what we did before. So those 4 multiplications that we did can be shorthanded, or I guess that's what I mean. The shorthand term for doing that is foiling them. But it really wouldn't matter, just so everything here multiplies everything here. And you can do it in any order. Now, these quantities are in descending order according to their powers. And that's why it turns out that this answer turns out to be in the proper order for the powers. The idea that you multiply everything in the first quantity times everything in the second quantity will help you when we move on to even more complicated multiplications. Say you ended up having to multiply a binomial times a trinomial. I'm just making this up. I'm trying to stick to small numbers so I don't make any mistakes. Everything here would have to multiply everything here, so this would be x cubed minus 3x squared. See, this is multiplying there, and then this is multiplying there, plus 4x. So the first term here got its chance at multiplying all 3 things in the second quantity. And now it's the 2's turn. The 2 will have to multiply everybody. The 2 times the x squared would be 2x squared. Now, I like to line things up and put things that are of the same type near each other. So instead of putting plus 2x squared over here, I would put it underneath. That's just my personal preference. You could put it over here and then gather it later. But I like to stay organized as I'm going along. And then this would be minus 6x plus 8. And then we draw our line, and then we add that all up, and we get the answer to that binomial times that trinomial. I'll use purple here. And we'll get x cubed minus x squared minus 2x plus 8. I hope you see the consistency of multiplying a binomial times a trinomial, or a binomial times a quadrinomial, if there is such a word, and a binomial times a binomial. Now, by far, the most frequently asked thing will be a binomial times a binomial. That's why I wrote this program. And you can see I wrote it in, I think, in the 90s. So it's really important to me that you get good at multiplying a binomial times a binomial. So let's see if we can't do some more of these, and you can catch on, and then maybe you can practice for yourself. You really have to get good at this. My high school algebra teacher, Mr. Cosgrove, used to make us do these multiplications in our head. He would call the 2 binomials out to us, and then he expected us to be able to answer it mentally. My dog is going to try to interrupt again. Sorry. I'm going to go back to the marker here, and let's go to a new problem. First times first is 8x squared. Last times last is easy. That's 8. Sometimes I tell kids, do the easy ones first, and then do the more difficult one. I think I'm going to have to stop here for a minute and take my dog out. Sorry. Thanks. So let's look at this second problem, multiplying binomial times binomial. We multiplied the first term times the first term and got 8. We multiplied the last term times the last term and got 8. Well, I should have said 8x squared for the first term. Sometimes I tell the kids to do the first times first and the last times last, because those are the easiest ones. The middle term is the one that takes the combination of O and I. So outside is 8x, inside is 8x, so this one would be 16x. Hope you can see how I did that in my head. We check, we win. Let's do a new problem again. First times first is 8x squared. Last times last is -5. I could do that, or I could just do it in the regular order. A lot of times students want to do things, the O and the I and then the L. But you have these three terms that are going to be in the solution if your original things are in descending order. That's the way it's going to work out. So, well, anyway, outside times outside is minus 20x. Inside is plus 2x, so that looks like a grand total of minus 18. You should get to the place where you can do that in your head. Then last times last is minus 5. Check, we win. We got 3 right. New problem. First times first, 4x squared. Outside, minus 4x. Inside, minus 24x. Minus 24 and minus 4 is minus 28. And last times last is plus 24. Check, we win. Now over here we have go to model multiplication. We've had a situation in the educational community where some people think that you could understand the multiplying of these two binomials together if we modeled these things using manipulatives. Unfortunately, they are kind of expensive. And I made these electronic manipulatives so that if we wanted to have, like, let's say 2x plus 2, no, 2x plus 3. 2x plus 3 could be modeled by these two squares for each of the x's, and then plus 3, these rectangles for the numerical terms, times, let's say an x plus 3. Then if we did first times first, we would get 1x times 2x would be 2x squared. And we'd see what happened there. We'd get an x squared times x squared. Then we have the outside. Let's see if I can think about that. The outside would be, I guess, this 9. Oh, outside times outside. I maybe have done that backwards. We multiply the 3 times the x, we get the 3x. Multiply the 3 times the 2x, we get the 6x. And last times last, we get the 9. Here comes the 9. That we could put down blocks for each of the x's and rectangles for each of the ones, and we could actually count them, but you could see that you get the same thing that you would get if you did FOIL. Let's maybe make up another problem like that. Let's say we created something. We said 2x plus 5 times 3x plus 2. Well, when we multiplied the 3x times the 2x, we would get 6x squared. See, they're squared boxes. When we multiply the 5 times the 2, we'd get these 10 little ones. That would be last times last. When we did it's hard to tell which one would be outside and which one would be outside, but 3x would multiply the 5, we'd get 15 x's. When we did the 2x times the 2, we would get 4. And so we could model this and see how we have all of these extra terms. But I think that people were pushed to do this because students would forget to multiply all 4 of the quantities together. But I think that you could get it. All your predecessors have. So let's get good at doing this. I think it's because we just never do it enough practice. 4 times 4 is 16x squared. Outside is 20x. Inside is 8. So we have 28x. Last times last is 10. check, we win. Do another problem. First times first, 5x squared. Outside, minus 4x plus 20x would make 16x. Sorry. And minus 16. Oh, that's right. With this program, you can push yourself to try to do things a little quicker, because nothing wrong with making a mistake now and then in practice, and so you can push yourself to go faster and then increase your accuracy as you go, speed and accuracy, because you want to be able to multiply a binomial times a binomial rather quickly, and it would be really good if you could do it in your head. Like I said, our teacher, Mr. Cosgrove, would walk up and down the aisles of the Algebra 1 class and just give us a binomial, one binomial and another binomial, and expect us to answer back orally what the product was. And the whole class could do it. Now, it scared me to death, and I was always a nervous wreck when it was my turn, and I didn't like all that, feeling that uncomfortable, but the whole class did it, and we all learned algebra. So use the program without the pressure, but get good at multiplying a binomial times a binomial. Thanks. Bye.